Hello, welcome to the NANOG tutorial track. I'd like to welcome Damon Garros, who will be talking about getting started with modern time series databases in Grafana.
Thanks. Hi, everyone. Very excited to be here. And so, yeah, as Jeff was saying, the topic today is really to talk about, how to get started on monitoring, telemetry, and all of that. And I've been working in, telemetry, I think, for the last 4 or 5 years. When I started at Juniper, I started working on the first implementation of telemetry streaming, and then I got a chance to move to customers, actually implement a lot of that in the real world and production environment. And now I'm with the Network to Code, and we're working with our customers. We're a consulting company and working with our customers to help them get started into network automation. So what we're going to do today to show you the end is really, we're going to show you how to build a dashboard like this one. And there's a lot of information and we're going to unpack. But what we are seeing here is a lot of information. We have at the bottom like visual representation of statuses of interfaces and BGP session. Like if you actually look at the right of the screen, the different colors are representing the different statuses of some BGP sessions. And on top, we have some traffic informations that have been aggregated per device, per roles, that are providing some very meaningful signals that you can action and alerts on your topology. So that's hopefully what we will have at the end of the session. But we have to cover a lot of things. So we'll have to cover how to build those dashboards. We're going to talk about why time series databases are, and those technology should be part of the toolbox of the network engineers. I understand a lot of you are not software engineers, they're not sysadmins, you're not going to deploy and manage those databases, but you are a user of them, and they offer a lot of very interesting capabilities. So it's very important that network engineer get involved in those discussions and understand how they can use them. We're going to talk about how to track interfaces and BGP statuses in a time series database. We'll have a very short introductions about GNMI, which is a new telemetry streaming interface. The goal of this presentation today is not really to go deep on GNMI. It's really about databases, but that's what we will use to extract the information from the device. And I'll show you how to install a time series database called Prometheus, how to collect some information with a collector called Telegraph, and then we will also explore Grafana and how to hook that together. Most of the sessions will be actually live demo. Just going to go through some slide at the beginning to make sure we level set, we have an understanding of where we're coming from, where we're going at, and all of that. But hopefully, very quickly, we'll get into the demo parts. So where are we coming from in terms of network monitoring and all of that in the network industry? So I will bet that most of you today are in these situations where you have what we'll call a legacy network monitoring solutions. You have an all-in-one server that is pulling information from the device, network devices using SNMP, collecting some traps, and everything is happening on this server. The collections, the storage, and the visualization. What you may not realize is that all of those solutions, whether they are OpenNMS, CollectD, Observium, Cacti, MRTG, all of them are actually using a single component, the same component at the core, which is called RD tools. That's what is generating those various query graphs that we all have seen. And honestly, this tool has been amazing when it got introduced in 1999. It offers some capabilities that were unprecedented back then. But nowadays, it's a very outdated tool. Like the issue is it's a storage system, but it's not a database. You actually store a lot of the information, and you also visualize them, and it doesn't really give us any capabilities to explore the data in what a new database, and that's what we're going to talk about today, can provide. Like there is no query engine. The data retention is really bad. It's very inefficient nowadays, and really there are some amazing systems out there that can replace that will offer new capabilities. The issue is, as network engineer, we are used now to not have those capabilities, so we're not asking for them. But if we realize what we can do with those new systems, then we can really do some amazing things. In terms of retention and downsampling, I don't know if you realize, but usually those RRD graphs, they always come in batch of 3 or 4. And you'll have like 1 day, 1 week, and then a month. And it's because the storage engine is actually very quickly losing data and downsampling. You have this you store for a day with some precision, and then very quickly you actually sample down, and you only save less information for a week and then for a month, which means if you want to go back to the data, you already have lost a lot of very critical information. The new databases that we're going to explore, they are way more efficient, and they don't have all those limitations, and you can actually store in a more efficient way, a very high granularity systems and data. That's one part. Another part of the network industry is we've been talking a lot about we got to kill SNMP, we got to move to telemetry streaming, everything is going to be open config, everything is going to be GNMI. And personally, I feel we've been kind of lost in discussions, and we've probably been focusing on the wrong problems. Like, all of that is about how do I actually extract the data from the network. There's very little discussions about how do I actually consume those data. Like, there's almost nothing out of the box that can consume telemetry streaming today. Like, it's actually super hard. People don't really talk about that. And at the end of the day, it's not really about should I push or should I pull, honestly. It's a non-debate. Like, outside of our industry, people are not so opinionated about that. If you need to build a SDN controller, yes, you need push. You need to have sub-seconds, information coming to you. But in most of the other use cases, it's actually not as big of a requirement. So we should not spend so much time, like saying, oh, I should do streaming or I should do SNMP. Personally, I feel, again, it is the wrong debate, and there are places for both of them depending on the use cases. So how are others doing outside of the network industry? And I usually like to look at the server infrastructures and see how, in terms of automation and monitoring, they are usually a couple of years, if not more, ahead of us. So on the server world, the way it works is, you usually have an agent running on the server that will be in charge of collecting the data. And then you'll have a data store, and you'll have another system that will be decoupled from that will be used to visualize or to do the alerting system. And what we're seeing is also we have multiple data stores based on the type of data that we are we want to collect and we want to visualize. We're at this point because the type of data are so specific that we have very specialized data store today. And in terms of how do we get the data from the server? Actually, there's as many push and pull solutions. Like, there's actually one of the most popular monitoring solutions that we're going to explore today, Prometheus, is using pull from the device. It's doing that in a way that is way more efficient than what we're used to. So we can, pull a lot of information from, thousands or tens of thousands of endpoints every 10 seconds or so. Without scalability issues. So again, depend on the tools, depend on the use case. That's not really the part that we should focus on. So what we look at that, we will really have disaggregated the stack. We have the collector, we have the database, and then we have the visualization engine, and each one is really focused on its system. If we look at the data, it's important to understand what are the type of data and what are the different, their specificity. So on one side, we have the metrics, or the time series, which time series and metrics are really applied to anything that is about numbers, counters, CPU value, number of peers, number of routes, anything that can be represented with the numbers will very well fit into a time series database. And that's something that you usually expect, coming constantly to you every few seconds, every 30 seconds, but something that you always get. And then on the other side, we have the logs, in the middle. The logs are structured data, more or less structured actually, mostly text. You can really predict when they will come. So, there's completely different type of data that requires different type of, databases and engine actually to process that. And then the last one are the structured data, which really don't fit in any of those more complex structures like the ARP table, MAC table, routing tables, all of those tables that really don't have a standardized way. And each of them requires a different pipeline, different database, different storage engine. The one we're going to focus on today are really the metric and the time series. And so this talk is only covering that part. There's a lot of open source projects that are very active in this space. I just wanted to give you some of them. In terms of there's a lot of collectors, a lot of databases, a lot of systems you can use for learning or visualization. I just wanted, please let's not be caught up in the tools. Like, honestly, if you get started with any of them, you cannot go wrong. Like, any of them will provide amazing capabilities compared to where we are right now. And there's a lot of the same concept and notions across all of them. They have their own, variations on the implementation side. But, it's this presentation is going to use Telegraph as a collector, Prometheus as a time series database, and Grafana as a visualization. But it's not so much about those systems. And hopefully, a lot of the things we will discuss in these presentations are also applicable to all of them. Like, all of them are actually very, very good and very popular. A little bit more about Telegraph. So Telegraph is the collector. That's the part that we will use today to actually extract the information from the device. I personally call that the Swiss Army knife because it's extremely powerful. It actually has this very flexible input and output plugins where it can collect data from hundreds of different systems and different formats, and it can, and it can also talk to many, many different backend and databases. So in this case, we're going to use it for Prometheus as a backend, and we're going to use a specific plugin that was developed by Cisco for GNMI. If you're not so much into building your own stack and managing it, and you want to focus on your core business, it's totally fine. Like, technically, a lot of the things we discussed today can also be applied in more of a cloud-based solutions, whether using Kentik or Datadog or any of those solutions. They can provide like basically cloud-based time series database solution where they will actually replace the database, the visualization, and all of that. Usually, you will still have an agent, either a generic one or their own, running on your side to collect. But at the end, again, a lot of those concepts also apply in those solutions. So now, let's look at how is it going to look like if we actually want to implement that on the network world. So we will use the same data store, same database, same tools to visualizations and alerting. And really, the part that will change is the collector or the agent. So first use case, if you have a Linux-based NOS, most likely, you can pretty much use the same agent that they have on the server side. So if you have, let's say, a Cumulus or an Arista, but that can be any other system that lets you install something on Linux. You can install those agents, and you will be able to extract a lot of information out of the box. Pretty much don't have to do anything special here. Then there's what I call the legacy device, the one that only exposes, for example, SNMP. So those agents, like Telegraph, they also have the ability to connect information, for example, through SNMP. And they can run outside of the device. They don't have to run on the device itself. So you can have an agent that will collect this information from SNMP to a lot of devices. That's actually probably the most common use cases where people get started into the network world and using those new databases with SNMP and with relational devices. And it works great. Honestly, again, SNMP is not perfect, but it's not something that should prevent us from moving forward in those directions. Another solution that I've seen, I personally implemented that works very well, is you can build your own collector, in Python, in Go, whatever language, and just connect to the device through their whatever APIs they provide. All the modern devices have advanced APIs, and so if you're working on a Juniper device, you can collect a lot of information with netconf at a pretty high rate, and export all those information to the database. And then the last one we should consider are the devices that are telemetry streaming. And so for those, there is a new generation of interfaces that are now available. A couple of years ago, every vendor was coming up with its own interface. Like I'm personally familiar with the one from Juniper called GTI. There's a typo on the screen. Cisco had also their own interface. And nowadays, all the vendors are trying to actually implement a standard interface for telemetry called GNMI. And so we have multiple collectors that are available on this field that can be used to store all of that. So we're going to have a quick discussions about specifically what is interesting about those time series databases, and then we'll move on to the lab. So the time series database really, it's really something, in my perspective, that started around 2013, really came mainstream around 2016. A lot of different projects, started to be very focused and dedicated on how do I store and how do I process and consume, those specific data of time series about counters and integer and all of that. And all of those systems actually have some similarity in the sense that they all come with a very powerful query engine, and they let you completely decorrelate how you store to how you visualize and how you consume. And that's what we're going to explore today. They actually have the ability to, and it's something we're not used to in this industry. Like we can store all the information about, let's say, the interface counters, and then we can actually visualize them and represent them in dozen different ways at any point of time, just based on how we're actually querying the data. So it's very interesting. Those databases are very different than the SQL databases in the sense that there's usually no schema. There's usually more read, more write, where we're constantly writing data to it than read. So that's why also we have such a specialization in this space for those specific type of data. And the way usually the data will look like in the database will look pretty much like that. So you have what some of them call the measurement name or SERI, which is really define what is the type of data. So here, that will be, let's say, I want to be, interface output bytes. And then you have a set of tags or label. They all have called differently. But what it means is the contextual information on in which context this information was actually captured. And so if I'm talking about interface counters, the minimum I need to capture is the name of the device and the name of the interface. But the idea is that you can have many, many more contextual information that will actually let you query those devices, and that's, again, what we'll be exploring in the other part of the talk. And then usually you have a value. So really, all the data that we collect have kind of these specific formats. And I'll skip to the labs, but we'll explore live, how to query that and how does that look like. So the lab, so I created this lab based on 6 different devices, 3 different NAS, iOS XR, GNOS, EOS. It's a basic like spine leaf topology with 4 spines, 2 leaves, a couple of servers to generate some traffic. And what we will have is we will have a server where we will install the time series database, the visualization, and we'll install 1 telegraph agent for every node. And this telegraph agent will use GNMI to connect to the device, query the information, and it will expose that to Prometheus. And again, we'll work through that. For information, this topology is running in the cloud in a solution called Tesudo. There's a GitHub repo that actually has, I think, all the instructions to recreate that. And Tesudo provided some coupon if you wanted to recreate this topology on your own. After, you can come see me, and you can basically have some voucher to spin that up on your own and try at home. So a little bit about GNMI. If you're not familiar with GNMI, GNMI is a new standard that has been introduced for telemetry streaming. It came out of the OpenConfig working group. And it's really actually an interface that can be used both to configure the device using OpenConfig, but also collect and subscribe to the states and the counters in the OpenConfig formats. So both of them. In this specific case, I'm not using it for configuration, just to collect the data. Nowadays, it is supported by most vendors. So the latest release of GNOS or Arista or iOS XR, for example, support that. And we're just seeing the first generations of collector in these specific fields coming up. So actually, I think I wanted to explore this idea, so I actually managed to get this multi-vendor environments working. I think we're still at the beginning of that. 100% is not really compatible between all of them yet, but I think it's heading into the right direction. So, and the way it works is it's using gRPC as transport, and the collector needs to open the session. So it's initiated by the collector, and the collector then will subscribe to some of the data and tell when he opens the sessions what he would like to receive, and that the device will actually stream the data after that. And I'll show you some of that, but again, if you have question about GNMI, I'm very happy to talk about after the presentation. This is not so much a presentation about GNMI. I guess people could do a full talks of an hour on it, but that's what I just to explore that I decided to use for this presentation. And specifically, I'm using a collector called Cisco Telemetry GNMI that has been provided contributed by Cisco to Telegraph. So it's part of the main Telegraph release. It's 1.11, and I actually was successful and be able to use that from 1.12.2 on other devices like Arista and Juniper. So if you want to try, and if you can just download the base image of Telegraph, and you will actually get that, and you will be able to use that. And last slide, before we actually get into the demo, a little bit about theory about Prometheus. So Prometheus is a time series database. That's what we're going to use for this presentation. And it is really focused on the storage and the query engine. And you can see there's a lot of things around it, but the usual component that we'll see is that first, you usually use an external system for visualization. So in this case, we're looking at Grafana. That's what we're going to use. Prometheus also has the ability to generate some alerts based on the data. We're not exploring that today, but it's actually a very powerful capability. It's very interesting, and usually relies on an external component called the Alert Manager that they're also providing. But it's used in many places to generate alerts and provide some insights on all of those data. And then on the other side, what we have is really how do we get the data? So as I told you earlier, Prometheus is about pulling the data. We call that scraping. And so usually we have endpoints that will actually expose those data, and I will show you later how that works in a specific format, and they expose that through a web UI. And then we just give this list of endpoints to the server, and the server will automatically scrape them on its own. And the formats make it that it's very efficient. There's also a way using what they call the push gateway to be able to get some information that are not able to expose this long-lived interface. So we have a way to collect both. It is usually common to deploy those systems coupled with what they call a service discovery mechanism so that the Prometheus servers will actually automatically discover those endpoints through some centralized service catalogs or things like that so that you don't have to manually update and keep track of all of that. But it's an all different topic. Some of those service discovery, for example, will be like it's natively integrated with Kubernetes, for example, so that if you have service running in Kubernetes, it can automatically be discovered and monitored with Prometheus. Some of the typical use cases. We'll keep things simple. We're not going to use service discovery today. We're going to try to explore the basics and hopefully show you how that works and how you need to think when you approach that in the network industry. So let's get to the demo, unless there's a couple of questions. But what we're going to do is, we're first going to set up Telegraph with Prometheus clients to expose the data and a GNMI on the other side to collect the data from the device. Then once we have all of those Telegraph agents and we're collecting the data from the device, we'll set up a Prometheus servers and we'll start to consume and scrape those data from Prometheus, explore some of that through Prometheus, and start exploring some of the query. So let's get started with that. If you have questions, please just go to the mic and we can. So I have a project again. I have I've written some playbooks to help me deploy those Telegraph agents. So I'm just going to run that and explain what's happening in the background while it's running. But what I'm doing with that is I'm actually starting 6 Telegraph agents on my jump host. So I'm on my jump host. Right now, if I look at Docker, I don't have any image running. So I'm going to have, in a few minutes, I will have 6 images of Telegraph, 1 for each of my devices. And to show you some example of the configuration, this is how a Telegraph configuration looks like. So we have the ability to define what are the output plugin and the input plugin we want to use. So here I say I want the output plugin to be Prometheus. Probably going to try to make that bigger. And then I want to say I want to use the input plugin. I want to use the Cisco telemetry GNMI, the one I was talking about. And then I will have to provide where is the device, login, password. And then the rest of the configuration is really about what do I want to subscribe to. And here, just because I wanted just some data, I'm subscribing to the interface stats. That's what I have here, /interfaces/interface, which is how things works in GNMI. I subscribe to a specific path that represents a specific data that is defined in the OpenConfig data model. And here I'm also subscribing to the BGP information and the states. Now, what personally I really like with Telegraph is they provide a very flexible system so that I can process the data before sending it to the database to make sure it looks exactly how I want. So for example, what I'm doing here is I'm telling it, what I'm going to get from my interfaces. I will get a lot of counters, but I also have some states. I will have some information that say my interface is up or my interface is down. If you follow the process, time series database are really about counters and numbers, not so much about up and down. So what I'm doing is I'm converting on the fly those fields, those statuses up and down into integer, like 1 for up, 2 for down, so that I can actually keep track of that in my time series database. And I'll show you later on how I can revert that back and represent that. And I'm doing the same for my BGP session. I'm saying, if it's established, assign 1. If it's active, assign 2. If it's connect, assign 3. If it's idle, assign 4. And so based on that, I can now keep track and alerts on those specific states, inside my time series database. So that's something that is done at the telegraph layer. So now that everything is working, I should have 6 telegraph agents running. Each one is actually exposed on a specific port. So if I go now to my server, on, let's say, a specific port / metrics, I can actually see all the data. And it looks very indigest. We'll also agree on that. It's not meant for us to actually look at. It's just more of a troubleshooting exercise or to understand how the workflow. But we have actually here all the information. And if I try to get one of them, let's say, admin status, what we can see here is actually exactly what I was showing earlier. I have the name of measurements, and then I have a set of tags that are defined. The tags that define the name of the device. I have a tag that defines the name of the interface here. I have other tags that are provided that I may or may not use. I'm using one to insert the role of the device as part of it. And then I have an integer at the end that actually defines my admin status, which is up here. So I have all those information that are exposed for each of them. So now let's move on to installing Prometheus. So usually you will install Prometheus as a long-running system. You will install that as a proper service. Here I'm just going to do the basics and the simple installations where I download the binary, lattice1, I unpack it, and I just basically extract. So since it's a Go process, I actually don't need much. All I need is a process itself called Prometheus. And if I start that, I will have a time series database. It can run on your lap, on a Mac, on Windows. It can run anywhere. That's the beauty of Go. All I really need is a configuration file. So the minimum configuration files you can have will be this one. That will So if what I really have here is that just tell it like every 5 seconds, I would like you to scrape yourself, actually extract the information about yourself because, as a database, we actually want to get some metrics and some information about it. Now, if I start that, I actually have a time series database running that will get, some information. By default, Prometheus exposes everything on ports 9090. So if I go here, I actually have the interface. There's some information we can go to. We can see actually what systems are getting scraped and what is the status is and some information. We also have a very simple query engine that we can use. So for example, if I wanted to see how many series and data are actually collected, I can have this information here. So you can see here right now we have about 500 kind of metrics and series that are extracted from the database itself. So, but right now I'm not querying any information from the network. So let's update the configuration to actually collect the information from the 6 collectors that I have running. If I go back to my system, I stop the existing one, update my configuration. And what I'm going to do now is I'm adding those new jobs, and I say now I would like to scrape every 30 seconds those 6 endpoints, which are representing the 6 telegraph agents that are running. Everything runs on the same host, so everything is localhost. But that's what it meant. If I restart the database now, and I go back to the UI, I will be able to see now I have all my additional endpoints, and they are slowly coming up. And now I can actually go in my in my graph, and I can query those information. So for example, if I wanted to see my counters, that will be interface state counters in octet. So in this case, that's the ingress octet that I'm getting per interface. And as I run this query, what I'm seeing is I'm actually getting, so we're seeing the data point here. It's very, very, it's just coming up. But basically, I have one series of counters per interface per device. So, and now it's all about how do I actually query that. So let's explore some of the things we can do. Like for example, I can filter and say I don't want all my devices. I only want the devices that are called, have the tag named device of type device that has a value of Amarillo. And if I do that now, I only have 6 interfaces, 6 value, which really represent the 6 data that I'm getting from this specific device. Now, what I have here is technically the absolute counters of those interfaces. It doesn't really give me the rates of traffic on those interfaces. If you see here, we have 60 million. So it's not very interesting to me. What I really want is I want to have the database to calculate for me the instant rates over a period of 60 seconds for each of those interfaces on the fly. And those systems are optimized for that. So now, and since there's no traffic, it's very straight and boring. But now I actually have some information and actually have the rates. I can actually do some math here. If I say I don't really want the octets, I want the bits per second, then I just have to multiply everything by 8, and now I actually have my bytes per second per interface. That's just a very simple query. Now, let's say that I am not so much interested about every single interface, but at some point I'd like to have a query that tells me what is the aggregated throughput for this specific device. So I will be able to say, now what I would like to do is a sum of all those interfaces grouped by device. And in this case, what I'm getting is I'm getting one line for my device where I have all the interfaces that have been aggregated together. And you're seeing it's very fast. The database are really optimized for us to dynamically calculate those things on the fly. If I remove the filter here and I say I don't really want to get that just for this device. I want to do that for all my device. And I want to group for all my device based on the tag device. Then now I can execute that and I can see I have actually one graph per device. I have 6 devices. So that's what I'm getting here. So you can see it's pretty powerful. Let me just start up some traffic a little bit in the background so hopefully we get some more interesting systems later on. So I'll just start some of that while we're exploring those other systems. So now, I don't know if you actually noticed, but here, I'm actually getting 6 interfaces, and only 2 of them are data plane. There's actually the loopback interface, the management interface. So I actually don't really want to aggregate, for example, those management interfaces. I want maybe to just look at my data plane interface. So I also have the ability to filter on that. And I say, I want my name that only starts with G, for example. And then now, I only have 2 interfaces, which are my data plane interface. So now we're actually getting into situations where I'm actually limited on what I can do here. Because if I want to only get some specific interface, I have to know their names. I have to know that this specific interface is an uplink, or this one is connected to a server. And and that's like the physical implementation of my system actually get into my queries. And if I wanted to do that across multiple vendors, that will start to get pretty complicated. So that's where we really need, it's very important that when we insert all those data into the database, we actually insert the right tags. Like, because I don't have the tags here that tells me what is the role of my interface, I'm not able to make a query that say, only give me my interface that are part of my data plane. But hopefully, because I have this flexibility, I can actually do that. And that's where Telegraph and its flexibility is very interesting, is I actually adjust the flag, but I'm going to regenerate my configuration for Telegraph, and I'll show you the difference. But what I'm doing this time is I will actually insert some specific rules for each device that say, if it's the interface 1, I know this one is a role uplink. So actually automatically insert a specific tag for this device. If this interface is interface 2, I know, so that's we have here, for example, on this specific device, Houston, I know that interface 3 is actually facing a server, so I'm going to insert a specific tag on every single information associated with this interface, and that will get populated into my database. I'm also inserting here the information about the neighbors. So I'm able to do that because in this specific system, I actually already classified everything. That's actually what I use to generate all those configurations. I use Ansible. So I have everything that is classified in YAML, and I can reuse the same information I used to configure my device to generate very specific configuration for Telegraph and make sure that it inserts all the right tags, all the right informations before I actually send everything into the database. And because I have those new tags, I will be able to, to make some more interesting queries and really focus on the role of those components and not so much about their names themselves. So now, where are we? My 6 collectors have been restarted, and automatically they should have been picked up. So now if I actually re-execute my query, it's not yet coming up. What I'm seeing here is now, where I used to have 2 results, now I have 4. And it's actually considering them as different because every time we have a different set of tags, it's considering them as a different series. That's how it works. So, but now what we're seeing is the new one, they have these interface role tags that here is defined as leaf. They have these neighbor tags that actually keep track of what is the name of my neighbors. And because I have all of that in the database, now I can use that as part of my query. So instead of saying, I want to see only my interface that have a specific name, I'm going to say, I want to see only a specific interface that have a role that is called leaf. And now I'm just getting that. And since this role is applicable across multiple of my system, irrespectively of which vendor I'm using, I can actually do that across all of my device. So now if I do that, I actually get all the interfaces on my spine that are facing my leaves for all of my spines. And if I actually go back to my query earlier and I say now I want to do the sum by device, but just for the interface that are a specific role for each of those devices, then now I will be able to have an aggregated value of my throughput per device only for the data plane interface on my spine. So I hope you really understand how important it is to have the right tags and the right labels in those places, because one mistake I was doing when I was at Juniper is we were all focusing about getting the data as fast as we can into the database, and we didn't really focus about that part. Like it was just about minimum number of tags that we could set. But honestly, I think that was a mistake, because if you don't have those specific tags, you will be very limited on what you can do. Now that I have that, I can, and I'll try to show you, I can do some very interesting query. So now we're going to move on. I mean, this interface is more troubleshooting, exploring the data, have some information. Most people really don't use that. When we want to visualize the data, we usually go with more of a dedicated solutions like Grafana. So now we're going to move on and explore that part of the presentation. Again, if you have any questions, please feel free to go to the mic and ask them. So here, again, I have just prepared, the command. I will go with the very basic of installing Grafana, just downloading Debian package, installing it. I will also install a specific panel, and I will go back to that later and explain, but basically I'm installing a panel. It's called Discrete. We'll explore that. And then now I'm just starting Grafana. So with that, I have a Grafana server running on my jump host. And usually Grafana is stored on port 3000 by default, unless you specify otherwise. First time you connect, it's admin, and you need to specify your own password. And then now I have a functioning Grafana server. The first step is to define the data source. So Grafana out of the box works with many, many different type of databases. The one we're using here is Prometheus. So if we select Prometheus, we need to provide some information about where is the server. And in this case, the server is on the same host and exposing everything on port 9090, so it's the default configuration. I didn't provide any authentication, so I will just save that. And it's telling me everything is working. It actually tested the connectivity. So now I have a data source configured. Once I have that, I can really move on into building a dashboard. So going into this plus sign, I can start creating a dashboard. So dashboard in Grafana is really a collection of graphs that are called panel. And so we can start, rebuild the one we were building earlier. It's very similar technically to the interface we had earlier. It's just we have more flexibility to make it look nice. So I can now, again, call my interface state counter octet, for example, and I can say I only want the one that have overall leaf, and I want to calculate the rate on that because I'm not so much interested about the absolute value. And again, if I do that, it will automatically show me all of my counters and my rate for my interfaces of a specific role. Now, where Grafana provide more is, we can actually tweak, like, for say, the legend. Like here, what I really want to see is just the information about what is the name of the device and what is the name of the interface, which is associated with the label called name here. If I do that now, I can see that I'm building a legend that start to make more sense to me. I can also define, for example, the metric here. So on the axis, what I can say is here I'm actually visualizing bits per second. So I have some specific information. I can define that my legend, I want actually to be as a table on the right with some data, for example, about the current data. So now I actually start to have something that speak to me, and I can see it's interface traffic uplinks. So that's one graph. I can move it around, and we have the ability to select how much data we want to see, how often we want to refresh those data. So that's things like Grafana provide out of the box. So now let's explore this other plugin I install. Let's say I want to start monitoring the state of my BGP session. So the state of the BGP session doesn't fit as a graph, as a line. So in this case, that's why I installed this discrete plugin that personally I found very interesting to save that. So the way it works is I still have to do a query, and in this case, my query will be, I have those information about the states of my system that are saved as BGP neighbor session state. And if I query that, I can see here I actually have a bunch of 1 and 2, which represent, if you remember, the actual state, like 1 minute established and all of that. So here, what I'm going to do, first going to reduce a little bit the size of those lines so we get more of them. And then this plugin actually let me do the mapping reverse. So here I can say now the value 1 actually means established. The value 2 was, what was the value 2? Active. Value 3 mean connects, and 4 is idle. So I'm doing the mapping reverse, and I will be able also to do a mapping based on the color. So here established will be green. I'll have connect active and idle. So let's say idle is going to be blue and active is going to be orange. Let's say connect is going to be, darker orange. So now I can actually visualize those information. I can give it name, for example, BGP status. And I can also assign a legend here, which will be, in this case, what is the name of my device. And I believe here it's peer IP. Let's show matrix name. That is not peer IP. That is. Actually, I can get it here. BGP neighbor address. That's what I was looking for. So now, because I have that, I can actually see exactly which BGP session we're looking at, and I will be able, to visualize all of those. So right now, all of them are established. So let's just shut one down so that we have something a little bit more interesting. So I'm going to go to one of my device. That is actually one of my leaf. So BGP neighbor. So we have all of them here, and I'm just going to shut down one of the interface. So at this, one of the interface will go down, we'll be able to follow the states, and 2 BGP sessions will go down as well. So you can see, we're starting to build those dashboards. So now, we can have a lot of information on the dashboard. One thing that I usually do is I have 2 dashboards. One that will have a global view of the network that will provide some aggregated value between multiple devices. But what's usually also standard is we'll have a dashboards per device. And so the way it will work, so let's say here we have 10,000 feet view dashboard. And we'll also have one per device. So I'm going to clone this one. And I will call it device. Now, since I want that per device and I don't really want to create a dashboard for each of my device, what I'm going to do is I'm going to create a variable that will dynamically let me choose which device I want to visualize. So here, I create a variable, I give it a name, and I say I want to dynamically query the value of a specific label and I give it the name of a specific measurement, and I say for all the tags that are value device. So here, showing me a preview, like that's the 5 device that I have right now. I think one of them is not properly reporting those sessions. And so now I have actually, I will be able to choose, and I have a variable that can dynamically take the name of, another device. So first, what you're seeing here, you're actually seeing, those BGP sessions that went from idle to active, for example, on the spine side, where the device, the interface is now down. So, we had this rotation. On the other side, the actually device, since the interface is down, the BGP session is just in idle mode. So now, if I just wanted to represent for some device, I will have to update my query, and I will say here, I only want to see the information for the device that actually map with my variable here. So if I do that automatically, since my variable is defined here, I can do that, and I will be able to switch between my specific devices. And in this case, since I'm just looking at one device, every time I don't really need to put the name of the device, but just the name of the peer. And then I will do the same for my interfaces. Here, I actually just looking at the device that are matching my specific device. And here, if I look at that, I actually see, have some specific information defined. So now I have a dashboard that is dedicated per device, and I can start, having some specific information on that. Any questions so far? I'm actually surprised. Yes.
Hi, Rinaldo Cis from Oracle. Can you elaborate a little bit more how you collect the metrics from the devices and you scrape from Prometheus?
Yes. So in this specific case, I'm using Telegraph. So I have one Telegraph process running per device. And I have an example of configuration here. And that's where for each device, I provide how to connect and what to collect using the path. So the path is something that is specific to GNMI. So Telegraph open a gRPC sessions to the device, and when you open the session, say I would like to receive the interface stats, and I would like to receive the BGP session stats. And so Telegraph get those information, and since I define Telegraph and I say, I want you to expose everything in the Prometheus format on a specific port, then I get that, something like that for each of my devices. So each of my devices actually expose those information. And here I have, one port per device. So 9002 is one, 9001 is another one, and that's how I get all my information from my device. On the Prometheus side, I created the configuration to match those. So here, you can see that Prometheus is actively scraping every 30 seconds all of those endpoints that I was showing you. And the format is actually, an agreement between the Prometheus client and the server that as long as I expose the data in a format that match Prometheus specification, then the Prometheus server will be able to scrape that. And every 30 seconds it will go and it will get all of those information. Does that answer your question? Perfect. So let's start a little bit more traffic maybe. So now there's actually some very interesting things we can do on that. Like we've just been scratching the surface here. Like for example, since I have all of those data and all of those capabilities into the database, let's start to explore, for example, what else we can do. So let's say that now I'm not so interested about, so let's say we're looking at the leaf, so that will be data, for example. And let's say that here, we're actually looking at either uplink or leaf. So what we can see here is there's actually, not a really good load balancing. My ACMP is not working very well. Now, if I look at it, I can see it. Now, what's interesting with the system is that they have a lot of functions and math and all of that will actually let me define and provide, metrics or signals that will be able to alert on. So, for example, there's a functions here that will let me automatically calculate what is the difference of rates between my interface. So it will be, if I say I want to calculate the standard deviations between a set of graph, I will get one line as a response that actually indicates, and the expectation is that if my ACMP is working perfectly, the deviation between all of those should be 0, because I will have exactly the same traffic on all of them. But now I can see here, for example, that my ECMP is not working, and so I have a deviations between my 4 uplinks that is actually pretty bad. And so I will be able, for example, using Grafana or using Prometheus itself to set up, let's say, an alert. So if I wanted to say, now I actually want to set a threshold as 1,000. So I know, based on my previous experience, that if my standard deviations between all of my uplink on a specific spine mean that I go over a specific threshold, either it means I have some very imbalanced traffic and maybe my system is not working properly, or maybe I need to remediate, or maybe there's something else, like maybe there's actually some specific errors on my interfaces that are dropping packets on one of the on one of the paths. So there's multiple reasons, but having that will be able to actually provide some very specific and actionable metrics. So that's just one example. Another example that I like to explore is if we go back to the global one. Let's say that now I would like to see, for example, if one of my devices is actually dropping traffic, one of my spine. So in this specific case, I have all the information about my spines. And because I have all of that, I can say I would like to configure the aggregated value for each of my spines by device. So here I see the aggregated value of ingress traffic for only the data plane interfaces for each of them. And I would like to subtract the same value of what I'm getting for incoming, for egress traffic. And so basically the idea is that everything that is not 0 means that I have more traffic that is incoming my device than what I have that is actually leaving my device. So as a spine, that's actually a signal that something is going wrong. So most of the case, you could expect to have some error counters that were going on that we could also show here. But in some cases, if you have a big chassis, that could actually have some drop inside the line card, some PFE, a lot of other places that you might not be able to see with the specific counters. But being able to dynamically measure everything's coming in, everything's going out, on some device on your network, you will be very quickly able to identify. And I can say here that in this case, this specific device, Amarillo, is dropping some traffic where it was not dropping anything before. And again, that's something I can now visualize, generate some alerts, understand. And if I look at my device, my 10,000 feet view, I can actually see that, and I can drill down and go back on one specific device and start investigating and getting faster to my root cause analysis. So we're almost at the end of the session. Is there any questions? Hope we were able to cover all the objectives of the sessions. Now you have a better understanding of what are those time series database, how to set up some collection with Telegraph, how to do the interaction between the collector and the database and Grafana, and you have some of the basic understanding of how you can use Grafana to start building some dashboards to give you some insight. And again, I think if there's one takeaway is that what's super important is to have the right labels on your data. And if you don't have the right labels when you insert them in the database, you won't be able to do as many interesting queries. So it's very important because those labels really are the reflections in some way of your network design. So as network engineer, it's really important that you get into these conversations with the people setting up their pipeline to ensure that they have a way to get those information, to insert them, and to work with them to make sure that, because for them, otherwise it's just going to give you a device name and an interface name and very minimal information, and you will actually be very limited later on what you can do and explore in your data. With that, I'll take any questions. Otherwise, I think we're done. Thanks. Again, if you're interested to set up the topology at home, there are some voucher that's provided by Tesuro, the cloud providers that you can use to set up your topology on your own.